we're supposed to define the terms. Remember, matter is anything that has mass and takes up space, two things. Units are just things that we describe measured quantities with. Significant figures are digits that reveal precision. That's 3 words. Digits reveal precision. Weight is how much gravity pulls on an object. Mass is how much matter makes up an object. And density, for density, you can just write density equals mass over volume. Okay? You can literally write the equation for your definition for density. Okay. Number 2, what are the basic metric units? Measuring length, mass, and time. What's for metric unit for length? Meters. How about mass? Grams. How about time? Seconds. Thank you. Number 3, you're reading a scientist's lab notebook and see a measurement of 14.5 milliliters. What was the scientist measuring? Which one was it measuring if you're using milliliters? Volume. Thank you. Number 4, you are measuring the volume of an object using a scale which is marked off with lines that represent 10 milliliters each. To what level of precision, 1 mil, tenths of a mil, hundredths of a mil, etc., should you report your measurement? Okay, so if it's marked off to the 10 mils place, what are you going to report yours to? Which place? The 1 mils place, because you're going to estimate to this digit, aren't you? 1 past the precision of the instrument. So the answer for that one would be 1 mil. Number 5, an object has a mass of that which is the same as that many slugs, which measures more mass, a slug or a kilogram? Okay, your best bet on any of these kind of questions is don't guess at it, actually do the math. Okay, so we have that 1 slug, let's do that one, 1 slug times line, and you know that slugs are going to go down here, and you know that kilograms are going to go up here, and you can go ahead and, let's see, where's the conversion given to us? Oh, we use these numbers. Okay, so we go 8.456 slugs to every 123.4 kilograms. And that's going to give us 14.59, 4 significant figures, kilograms to every 1 slug. And so then we can answer the question, which measures more mass? 1 slug would, because 1 slug equals 14 plus kilograms. Okay, so just do the math on it. Number 6. A box has a volume of 1.01 meters cubed. 2 students measure the box. The first says the volume is 1 meter cubed. The second says it's 1.23 meters cubed. Assuming they are reporting the correct number of significant figures for the measuring device used, which student used the more precise device? First or second one? Second one for sure, because there's more digits out, aren't there? And then which student provided the more accurate answer? The first one. Okay, because it's closer to reality. How many significant figures are in the following? How many are in A, 7A? 3, 1.6, all 3 of them. That's why I like that kind of thing, the scientific notation. How about B? How many significant figures are there? 2, because with 12,000, these zeros are not to the right of the decimal at the end of the number, and they are not between 2 significant figures, so you can only count these 2, can't you? Okay, on this one, how many significant figures? 3, because this 0 is to the right of the decimal at the end of the number, so it's significant. These, the first rule, they are non-zero digits, so they're significant. But these are not between 2 significant figures. They're not to the right of the decimal at the end of the number, so there's only 3. And then the last one, 1.0, that, how many significant figures? 2, because that's to the right of the decimal at the end of the number, so you would count both of them, 2. Okay, number 8. On number 8, it says, when you put ice cubes in a glass of water, the ice cubes float. What does that tell you about the density of ice compared to the density of water? Ice is less dense, therefore it floats. The water's more dense, so it goes to the bottom. Number 9, when a figure is significant, does that mean it is mathematically important? No, David's back there going like this. No, it does not. It's not mathematically important. It's chemistry important because it tells you something about the precision of the instrument used. Number 10, 2 students are measuring the mass of an object. One reports his answer to be 4.56 grams, while the other reports it at 4.58 grams. The teacher gives both 100% credit. How can they both be right? What are they doing to the last digit? Estimating it. So it's going to be a little bit on what you think you see. Number 11, a carpet layer measures a room at 4.6 meters long and 3.2 meters wide. He multiplies the two measurements and reports the area of the room to be 14.72. What two things are wrong with his answer? What's wrong with it? Too many significant figures and no units. That's right. So make sure you do those on your test. Number 12, what is the correct answer for the following equation? Okay, so if we do 21.0234 grams and we subtract from that 12 grams, the answer that we get is, well, you would get an answer with a whole bunch here. I'm going to just do it for you. 21.0234 minus 12. Yeah, the answer you get in your calculator is this, but we are adding and subtracting. You have to go to least precise. The least precise is to the ones place. So my answer has to be to the ones place. So this will be just 9 grams will be my answer. Let's see. A U.S. dime has a diameter of 17.9 millimeters. What is its diameter in meters? So we have 17.9 millimeters, and we want that in meters. So we go times line, millimeters to meters. One of these is 1,000 of these. So it's, I'm just going to rewrite it, times 10 to the negative third meters. So that would be 1.79 times 10 to the negative second meters would be the proper significant figures. If you're doing them in your calculator, you're going to get that. So let's see. Soup can has a mass of 490 grams. What is its mass in kilograms? So we have 490 grams. We want to know its mass in kilograms times line. This unit always goes here. We can go directly on these, can't we? So it's going to be 490 times 10 to the negative third kilograms. So that's going to be 4.90 times 10 times 10, 1, 2, to the negative first kilograms. Or you could have written it this way. You only got 2 significant figures here, so your answer has to be in 2 significant figures. So watch that, okay? Number 15. Number 15, the volume of a soccer ball is 6,080 milliliters. How many kiloliters is this? So we go times line. The common unit is the liter. This goes here. Now we can go to kiloliters. One of these is 1,000 of these. One of these, that's the big one, is 1,000 of these. And so then you would go ahead and do your math and answer in how many significant figures? You tell me. How many significant figures does your answer have to be in? 3. 1, 2, 3. That 0 is not to the right of the decimal at the end of the number. So it cannot be counted into your answer. 16, an object has a length of 15.0 inches. What is its length in meters? And it gives us here the bridge between centimeters and inches. So I'm going to go like this, and I'm going to go inches to centimeters. That's the bridge I'm given. Then I can go from centimeters to meters. I know one of these is 100 of these. And I know 1 inch is 2.54 because they gave it to me. And then this will cancel, and you'll be left. How many digits have to be, significant figures have to be in our answer? 3. Very good. Okay, so you would answer that as 0.381 meters. All right, number 17. Are you guys okay with your scientific notation, putting it in a scientific notation? Okay, let's keep going. Number 19, a bowl has a volume of 1.1 liters. What is its volume in cubic centimeters? So we want to know this, which is the same thing as this. So we're going to go times line. We got to get to milliliters, don't we? Now once we get to milliliters, then we can go to cubic centimeters, can't we? So one of these is 1,000 of these. This is a 1-to-1. These will cancel. You just go across, and it's 1.1 times 10 to the third centimeters cubed. Did everybody get that? Are you guys tracking? Are we okay? Still trying to make it so you can do your lab, so we'll see. Okay, number 20. A sample of a liquid has a volume of 143.6 liters. What is its volume in cubic meters? Once again, we have to go through the milliliter centimeter cubed bridge. So we're going to go here to milliliters. Then we can go from milliliters to centimeters cubed. Then we can go from centimeters to meters. And when we cube this, we've already seen that if we cube this, it's going to be 10 to the 6th. We've already seen that today, haven't we? Okay, so then we go 1, this is 10 to the 3rd, this is a 1 to 1. We give our answer in 4 significant figures. Okay, the most important thing is your bridge. Make sure you can build these bridges and that you're putting your numbers in the right place. Number 21, alumina has a density of 2.70 grams per mil. What is the volume of an aluminum block that has a mass of 55.67 kilograms? And we want to know, we want to know its volume. We know that rho equals mass over volume. The mass, it's got to be in grams because this is in grams. So we're going to go times line. Kilograms, grams, 1, 10 to the 3rd. So we're going to go 5. I'm just going to make it easy. Grams divided by the volume, which is 2.70 grams per mil. How many significant figures does our answer have to be in? 3. There's 4 here, there's 3 here. So your answer has to be in 3. So it's going to be 2.06 times 10 to the 4th. Whoops, grams leave, milliliters. We're left with milliliters, which is what we're looking for because we're looking for volume. If your units don't line up, then you know you're in trouble. A sample, go back and check what you did wrong. A sample of what looks like silver has a mass of 1.7 kilograms and a volume of 0.164 liters. It gives us the density of silver at 10.49 grams per mil. And it wants to know, is this really silver? So we go rho equals mass over volume. The mass, I'm going to take this to grams per mil because that's what this is in. Okay, so this is going to be 1.7 times 10 to the 3rd grams divided by, this is going to be 167 milliliters. You would do those 2 calculations at this point. How many significant figures are going to be in our answer? 2. So the answer we're going to get is 10, and I'm going to put my decimal there to show that that is a significant figure. 10. Is it silver? Probably, right? So it's probably silver. I would say yes.